Alright guys, well, welcome back to my Kwiky burner for my home foundry. I built this little orifice and surprisingly it works amazing. When it's set down in here, and I milled this little flat and put that set screw so it has, when it's inside, it can move from one end to the other and set the difference. So, but when it drops in, I have really no control. Like, I can't move it at all. Just gravity kind of drops it. I can push it in with an Allen key at the end or my finger. But if I wanted to move it out and then move it back in, I have no control. So I've been pondering how to make this work for the last 2 days. And I've come up with the idea of this piece of stainless steel. It's just a scrap off a shear, and this is a little water cut job, so there was a part in here. Anyway, so as I said, it's 3/16, or supposed to be 187,000. It's 180. And I picked that piece out of my scrap pile because inside here there's all the pieces that you've seen in the earlier videos. Well, this is a 3/16 Allen key, and I'm suspecting 2 to 3 inches being inside the furnace, at least 2 inches of it. So I want to be able to control that little Venturi from outside, move it, be able to move it on the fly. So I started running through my Allen keys. I don't have anything, a pin gauge that long. So I started, and I figure if I just have a little slot cut here, and I use this Allen key to check the size of the material, and it goes in right down to the end of the Allen key. So we pull that out and transfer that distance. It goes right down to the compressed air, that pipe coming in. It'll go down and almost hit that. So I need a piece of steel that size or smaller. And from this end here to that little notch is pretty much perfect. I could make it shorter if I want. Shape it. It's going to need to have a radius ground on it to match the inside of the tube. And I'm going to cut an oblong slot here. So what I'll end up doing is drilling and tapping a hole here. And then I'll put on this end maybe like a knurled thumb wheel of some sort, and I'll thread it into the knurled thumb wheel and then just put Loctite so it's attached as a bigger thumb wheel. So undo it a half turn or whatever, and this will be able to slide and lock up. So I want the thumb wheel roughly just below this little blue manifold right about here. And this is going to involve taking this whole assembly back apart. The other thing is I'm going to have to, I already have that flat milled, so I'm going to have to machine another slot with a little finger to pull and push this Venturi. So I'm not sure if I'll be able to mill that into this, because this can get thinner. It's going to need a radius on it anyway. Yeah, so a lot of it will come down to fitting. But in the end, it's going to be attached. And hopefully the inside of that burn tube will trap the stainless steel and lock it into that little Venturi. And then I'll be able to use the screw. This is a 1032 or a 13/16. And I'll be able to just unloosen it and slide it forward, back, whatever suits the need. The problem that I witnessed is when it was set to the front of the nozzle flush somewhat, it had enough combustion air, not combustible air as I was pointed out, enough combustion air to atomize the diesel here. But it slowed down the it's not compressed air, but it's a turbine pressurizing and using the combustion air. But what I'm thinking is once the furnace gets hot, this is just an oil drip burner. I could move this further away, and I don't need as much atomization here at the nozzle. I can move this further away and increase combustion air. And if it doesn't work, it'll just be a really neat add-on. With my test with water, it did work. When it was back at this point, it atomized the water really well. And when you slid it forward, the airspeed through the Venturi around the nozzle tip slowed down with the increase. So the tip was kind of further back here, and it was bringing in more air, but compressing it less. So that's what I think will work, and off to the machines to get her done. Thanks for watching, guys.